students, today we are going to see a topic called functions. Okay, functions. So what is a function? Function is a set of code. Function is a set of code used to accomplish a particular task. Function is a block of code used for accomplishing a particular task. Correct? Chalo. So let me write that. Function is a group of statements or a block of code which is used for accomplishing a particular task. Can I write like this? Group of lines to accomplish a particular task. So I'll write here printf. I'm writing a group of statement. Hi. Then printf, hello. These are my group of statements. Okay. Here my intention is to print hi and hello. That's it. Okay. This is a block of code. Okay. Now this is said to be a function. This is said to be a function because it is there in a block of code, and you have to give a function name. So I'll write here function name, demo as my function name. Okay. Every function has got this parenthesis. Every function has got this parenthesis. Okay. Now this particular function name is demo function, which contains some group of statements. Okay. Now let us see what is the use of function, why we have to go for a function concept. Okay. Why we have to write the set of code only in a functions. Okay. The first thing is, in order to achieve the code reusability. Write once, code reusability. Write once and call many times. Write once and call many times whenever it is required. You may have a doubt. Okay, as we know, for loops are there. Write a code, simple code. Write this code. Okay, I'm writing this code. The same code which I wrote above, I'll write the same code. 2 printf statements. Hi, hello. That's it. One simple code. And as we know, this is a block of statement. If at all you want to execute for multiple number of times, we go for a for loop, correct? Yeah, we go for a for loop. Let me say 4 times. Okay. So what is happening here? The same block of code will get executed 4 times. Hi, hello will get printed 4 times, correct? Hi, hello will get printed 4 times. Like this, 4 times it is going to print. Yeah, it's only 3 times because I wrote only less than 4. That means this is for 1 time when I is equal to 1. This when I is equal to 2. This when I is equal to 3. Again, I becomes 4 equal to will come out of it. That means the same set of code got executed multiple number of times. But is it getting executed continuously or else whenever I want? It is getting executed continuously, which I don't want. How I want is, I wanted to have a set of code which has to get executed only when I call it. Okay, not continuously like this. Okay, that is the main difference between function and the for loop. Okay, looping statements are used for calling the same code, like executing the same code multiple times, continuously multiple times. But coming to the function, executing the multiple statement, executing a block of code, but when it is required. Okay, for example, now I wrote here demo, correct? So I can write here, I can write a program, let us say I can write a program like this. I'll call demo for the first time. I'll call demo is my function, I'll call it. Okay, for the first time. Then where should I call? I should call in a main function. I'll just tell you how to write. This is only an example. Okay, demo is being called first. So this will get executed, the control will go to demo and the statements will get executed. So first time hi, hello got printed. After that, here I'll write printf statement saying bye bye. Okay, now the second statement will get executed, that is bye bye. Bye and bye will get executed. Again I'll write demo. Again the control will go to demo and it will get executed. So again hi, hello will get printed. Okay, that means a block of statement will be called whenever I want it to get executed. That means write the code once and call it multiple number of times whenever it is required. That is called code reusability. Write once and use many times. Write once and use many times. Call multiple number of times whenever it is required. Then the second use of the function is readability. Code readability. Okay. If at all you write a very big code, like for example some 50 lines of code, okay, when you look at the code, it will be very clumsy and very lengthy code. If at all you divide the code into multiple modules or multiple functions, then the code readability will be very good. We will understand what is happening in each line of code. Okay, readability will be very good. Okay, understanding the code will be very easy. And the third purpose of code functions is debugging will be very easy. Debugging will be easy. If at all something goes wrong, instead of checking complete code, we can go to a particular function and do the correction only in that particular function. Okay, debugging will be very easy. Easily the code can be manageable. Even it may be a very lengthy code. Okay, managing the code will be very easy if at all you write the code in a functions. Okay, all the softwares, whatever the softwares right now we have, all of the softwares will be divided into small modules, and those modules will be integrated in a single program. Okay, that becomes a project or application. Okay, and dividing a big program into small modules. Again, that small modules will be integrated or clubbed into encapsulator into a single code. Okay, so that one is called your application or project. Okay, like that. Now we are writing a function, small function codes we write in our class today now. Okay, then we have seen what is a function. Function is a block of code used for accomplishing a particular task. Okay, then what are the uses of code? What are the uses of functions? Okay, the function, whenever you use a function, code reusability will be there. That means write the code once and use it many number of times whenever it is required. And code readability will be very good. That means a lengthy code can be divided into small modules, and we can again integrate all of them into a single code, so that the code readability will be very good. We can understand the code just by looking at that particular code. Then debugging will be very easy if at all you write a functions. Okay, then comes what kind of functions we have. We have basically two types of functions. Basic types are two types. One is called predefined functions. Predefined functions. Predefined functions and user-defined functions. User-defined functions. Predefined functions are like already defined. For example, already defined whenever the compiler was designed. So printf is there. Are we writing the code for printf? No, we are just using it in our code, right? What does the printf do? Printf will print whatever it has been written in the double quotes, correct? Like it has got few more specifications. When we talked about the printf statement, you might be knowing about this, correct? So printf is a function used for printing something, right? Now, in a similar way, we have so many functions. Scanf is one more function. Like that, we have got so many predefined functions. Where are these predefined functions exist? These predefined functions exist in a header file called standard input output header file, stdio.h header file, right? Similarly, if at all you want to write your own codes like printf and scanf, then that particular functions are called user-defined functions. User-defined functions. For example, I wanted to write a code for add function. How do we write? Simple. First of all, how to write a function. How the function, what is the syntax of the function, how to write a function. Okay, let us see now how to define user-defined, how to write a user-defined functions. Okay. So the syntax of the function writing is like this. Syntax will be like this. First you have return type. Then comes name of a function. Then comes parameter list, or we can say it as parameters or arguments. Parameter list or argument list. List of arguments will be there here. List of arguments. Okay, list of arguments will be there. Okay. So let me write this. What is this return type? So let me take an example. I'll just write return type in the sense return type can be void, int, char, float, double, structure, pointer. Return type can be anything, structure like this. It can be user defined data type, or else basically primitive data types also can be a return type. Okay, we'll see the examples how exactly this return type will work. Name of the function. As we know, identifiers has got some rules, like name of the function also have the similar rules. Function name must not contain any spaces. It must start with a small. It must start with the alphabet. Okay. Company specific. Okay. This is the name of the function. Then it contains some parameters. Parameters in the sense arguments. We can say arguments like this. We can write the arguments like this, if at all you want. Okay. Return type means these things are called return types. It can be structure type or array type also. User defined data type can be there. All primitive data types can be there. And the name of the function. Like we are going to give any specific name. It can be any name. Okay. And the parameters can be anything. Like arguments can be anything. Okay. Let us see few examples. First, we'll talk about what is a return type. Let us say I just want to write over here void demo. Okay. I'll write here printf hi. Okay. Now you may have a doubt how to write a function in the program. Correct? You have that particular doubt. Okay. For that, simply see. Function can be written in two ways. One is, first I'm writing name of the function declaration. This particular part is called function declaration. Function declaration. Okay, then write down the main function. Inside the main function will be called. Then function definition. If at all the function get called, what has to be done? What is the code has to get which code has to get executed? Okay. Let me write over here printf hi. I'm writing. Okay. So we know that always the compiler starts execution from the main function. Okay. From here it will go inside. Okay. There is some function call. That function call is let me write here. The function call is demo. Demo is the function call. It is calling a function called demo. Okay. Immediately the compiler will go and see above, like global declaration part, whether the function declaration is there or not. Okay, function declaration is there. Then immediately it will search for the function definition. Definition in the sense, this part is called function definition. Function definition. Okay, function definition. Okay, what has to happen? Okay, it has to print hi. Okay, it is printing hi. This particular one will print hi. Done. Hi got printed. Okay, this is how the program will work. And we have one more way. That is, instead of function declaration, we can declare and define at the same place. We can declare and define at the same time. Globally. Then you can write void main. Function calling has to be done in the another function. It's not like we can call inside that also. Function can be called inside the function also. But right now, as an example, I'm taking it is being called in the main function. Okay. The program execution starts with the main function. Again, the first line is demo itself. The control will go to demo, and here it is going to print hi. Okay. Understood? Done. Now let me tell you about one more keyword called return. Return means go back to the place from where the control has come. For example, here, who has called this demo function? Main function. Okay. After executing the block of statement, where it has to go? Like for example, hi got executed and it has printed hi. After this, the control will be here. It has to go back, right? So I'll simply write here return. Return means go back to the place from where you have come. Okay. Simply return. There is nothing. Only simply return. Okay. So return means come back to the place from where you have come. Okay. My control will be here now. Okay. After that, you don't have any instruction, so it is okay. And you need to know one thing about the return. Return can return only one thing. Return can return only one variable at a time. Return can return only one value at a time. Only one value at a time. Only one value at a time. Okay, one function can return only one value at a time. Okay, understood? Only one function can return only one value. For example, I'll tell you one example. Let us take integer type. For example, here I am writing, see, my function is demo, int demo1. Here I am writing int a is equal to 25, int b is equal to 30, int c I am declaring c is equal to a plus b, return c value, return c. What does this c has? Now the program, this function will be called in the main function. Okay, I'm writing the main function to main function. I'll just call demo1. I'm calling demo1 function. Okay, immediately what happens is the control will go to this particular place. Then memories will get allocated for a, b. These are local memories. These are called local variables, and local memories will get, for every function memory allocation will be there. Memories will get allocated for them. Okay, here what is the computation being done? Sum of the two numbers. Okay, the sum of the two numbers is 55. Then return c. Return c means whatever the value you have in this particular c, that will be returned back. That will be returned back to this place. Okay, what are you returning? What is this c variable? What is the declaration of c variable? It is integer. That means if we can say over here, this function gives you integer value. Whenever you call this particular function, it will give you integer value. Okay, that integer value is c, right? So we need to specify that whenever you call a function, you are going to return this function is going to return an integer value. Okay, when integer value comes, it has to be, the answer has to be held into some integer variable. So I'm writing over here d is equal to demo1. After that, I'll print the answer here, printf %d. What is the value present in d? It is returning c value. What do you have in c? 25. This 25 will be in this place, like this here. This 25 will be placed into your d, and the value of d will is d is 55 will get printed. Is it clear? Okay. Now, if at all, let us suppose this is float type. This, instead of integer, I am writing float c. Okay, float c. If at all you perform addition of two numbers, your float value will be 55.00060 will come. Okay, what I am returning? C. What is the type of C value? What is this variable C? It is of which type? Float type, correct? So immediately we have to say this function returns a float kind of variable. So if at all it is giving a float kind of variable, where you are going to store it? It must get stored in a float type only. Okay, then only we'll get the answer in a perfect way, whatever we want, or else you are going to do it typecasting. So now, right now, we're not talking about typecasting and everything. We're just talking about the return type. So I'll just focus only on the return types. Okay, is it okay? Then comes, for example, I have over here char some variable, char some I is there, char I is there. In this we are writing a. Okay, now I want to return this I. What does this I contains? What is this I contains? I contains what? A. I want to return I. Return I. I means A has to come to this particular place. So what should I do? What is the type of I? I is char. So you must write over here, instead of float, you must write over here char. Char. Okay? Okay, when you are returning char, we must have some variable which could able to hold the character value, right? So I'll write over here. Even here I'll change it. Even there I'm going to change. I'm simply writing over here char. I'll simply write here char. I'll simply write over here char. some variable, let me say x equal to demo1, x equal to demo1. Okay, then printf what is the character present in x. Okay, this whenever this demo1 is returning something, this I value, it is returning I value. What is this I containing? A. Okay, for this demo1 it is giving you a I value, that is a, that will be loaded into x. Now we are printing what you have in x. I hope you understood this one, cat. Why did we write cat? Because we are returning I. What is this I variable? The return type, the basic data type of this I is cat. That is the reason I am writing over here cat. Okay, then this is all about the return type. Okay, now let us talk about in how many ways we can write a function. In how many ways we can write a function. Okay, let me go with that. In how many ways we can write a one program, in how many types of functions will be there, in how many ways we can write one program. Okay, using a function. Function program can be written in four types of functions will be there. First one is called with no return type. With no return type, that means if at all someone calls, it is not giving any value back. With no return type and no parameters. And no parameters. Okay, let me take example of the same thing, that is addition of two numbers I'll perform. My first program is this. Now in this program category I am declaring and defining at the same place. Okay, so I'll write here void add I'll declare the variables inside only a, comma b, comma c, scanf, %d, %d, read the values into a and b, perform the computation c is equal to a plus b, and print the answer also here itself. Okay, and go back from where you have come. Go back, return. Don't give anything, just simply return. Don't give anything, simply return. Okay, then now I'll write a main function. Void main. What are you calling? You're calling add. Okay, I'm calling add. Then I'll call it one more time add, and then I'll say printf this is add function. Okay, this is add function demo. Then I'm calling add once again because I just wanted to see how much, whether it can be called or not. Okay, so I'm calling these many times. So first time add got called. When add got called, immediately three local variables will get created. Memory for three local variables will get created, a, b and c. Immediately then what's the next statement? Scanf, read the values into a and b. Okay, I'm reading the values into a and b. Then I'll perform the computation. The computation is a plus b is 3, and we are printing the answer here itself. And return. Return means come back to the place from where you have come. Okay, now the return. The control will come back to this particular place. Okay, when it has come, all the local variables which got created for this function will be taken back or destroyed by the operating system. All these memories will get destroyed by the operating system. Okay, again second time add will be called. When second time when add got called, again the control will go to this particular place, and again new memories will get created. This time new memories will get allocated, a, b, freshly new memories will get allocated. Okay, again we are going to add two values, so I'll read two values like 5 and 6. 11 is the answer that will be loaded into C. I'm printing the 11 as one more answer. Okay, again the control will go back to the place from where it has been called. Okay, it will come back. Again it is going to print this is this add this is a add function. Actually I wrote here some mistake. This is add function demo. This is add function demo. Okay, this is add function demo. Is it clear? Again After completing this, we are going to the last line. What is the last line? Add. Again, the control will go back to add. Okay. Again, new memories will get created for A, B, and C. This time we are going to read 15, 16. The answer is 31 will be computed. 31 will be printed at the end. Again, return. Return means go back to the place from where you have called. Okay. Then nothing is there, so it will stop the execution. So this will be our output. Is it okay for you? Okay. In this concept, what we have studied is we are simply returning. We are not giving any value back to the main function. Are we giving any value or any data to the main function? No. So we are simply returning back. So multiple times what we do is, many times what we do is, if at all you have empty return, we don't write it. Okay, now also I'm removing. If at all you have empty return, we don't write it. It's only for the explanation purpose I wrote. If at all you write also, no problem, you won't get any error. But it is not required also. If at all you don't write also, you won't get any error. If you're not giving any value back, you're going to write over here void. That means I'm not returning anything back. Okay. Do we have any parameters here? No. That is the reason this particular method of programming, this method of writing function is called no return type and no parameters. Done? Then next, the same code, but we write with the second one is with parameters and no return type. With no return type and with parameters. I'm writing with parameters now. Okay, no return type. This is return type. With no return types and no parameters. And with parameter. What does it mean? See, what does it mean is, let me write the same thing what we have done just now. Add. I'm writing here two parameters, int A and int B. Int C is equal to A plus B. I'm printing the answer here itself, percentile D and C value. I'm printing the answer here itself. And this time I don't write return because you understood. After completion of this code, we are going to return back to the main function. Okay. I'll write here void main. Here I'll write add 5, 6. That means the same code is being called multiple number of times whenever we want. Like this. Okay. So now this argument is 5. 5 is an argument. First time whenever we call 5, add 5, 6, immediately the control will go to this place and memory blocks will get created for A, B and C. And the 5, which is the actual argument, that will be loaded into this A. Okay, then the computation will be performed. C is equal to A plus B, and the result will be stored back on the will be printed back on the console. 11 will be printed like this. Okay, then it will when it will come back. No, at that time, what happens? All these memories will get destroyed by the operating system. It will take back again. Add 1, 2. Again, this function will be called again. 3 memory blocks will get created. 1 for A, 1 for B, and 1 for C. This is A, this is B, and this is C. Then 1 will be, the actual argument 1 will be stored into A and 2, and the computation is 3. It is going to print 3. Okay, like this. These arguments, these are called parameters or arguments, right? These are actual arguments, right? So that will be loaded into this formal arguments. Okay, understood? Okay, these are my actual numbers, right? That will be loaded into these variables, correct? So this particular function writing is called with no return type. That means I'm not returning anything back. Am I giving any value back to the main function from the add? No, I'm just printing the value on the console. I'm not giving back anything to my main function. So this is called with no return type and with parameters. Okay. And the third one. Now let us look at the third one. We have with return type. Third one is with return type and no parameters. and no parameters. Okay, how to write this? This is very simple. So I'll take the same example. This time I'm returning back. What am I returning? I'll tell you what I'm returning. I said no parameters. Then here itself I'm going to read the values for A, B, C, because the first one I'm using A, B, C are 3 variables. I'll read some values into A and B. I'll read some A and B values. Then I'll do the computation. C is equal to A plus B. Then I'll just whatever the C value I have, that I'm going to return back. The C value, whatever I got, I'm not going to print here. I'm going to return the value to the main function. In the main function, I want to print that, or else I want to use for the further purpose. Okay. Right now, I'm using only for the printing purpose in the main function. Instead of printing in the in the add function, I'm printing in the main function. See, look at this. First time I'm calling add. Add. I'm calling these functions add and add. Okay. First time I've called this function add. Immediately the control will go to this particular place. Then 3 memories will get allocated for A, B, C. Then we are reading some value into A, some value into B. Let me say 1 and 2. Then the computation will be done, that is C. Computation is being done and return the value of C. What is this C? What kind of variable is C? Integer type. That is the reason I wrote here. We are returning an integer number back. We must tell this what kind of number this function is returning. Is it returning anything or not? If it is not returning anything, we need to write void. If it is returning something, we need to write here what kind of data it is returning back. Okay, I wrote here int. So that means we are getting some integer value. Okay, here I got the integer value. That data has to, that whatever the data we got, that must be held by some variable, no? So that's the reason I'm taking one extra variable called D, E and F. In this D, I'm going to load this answer, whatever we got. Okay, immediately I use printf statement, printf %d. Whatever you have in D, just print it. Okay, first time it is printing 3. Again, I'll write here. Again, I'm calling I'm calling D is equal to add. That means again add function will be called. Again 3 variables will get created. This time I'm writing the variables as 2, 4, 2. So the answer is 6. That will be returned back. So this time the D is going to print here. Whatever the value contained in D is, that is 6. Whatever the value this D contains now is 6, because it is written the C value. The C value is 6. The C value will be loaded into D. Again I'm calling add. Third time I'm calling add. Third time I'm calling add. Again the control will go to this place. Again new memories will get allocated for A, B and C. Let us say this is 11, 14. This is 20. 14 and 20, and the computation is being done. That is 34 is your answer. Okay, 34 is your answer. That 34 I'm going to load into a variable called D. D is equal to add of this. Then I'll print this %d. Whatever you have in D, that it is going to print back. So 34 will be printed at last. Okay. Okay. This is how the function will work. This is the third kind of function. Now let's go with the fourth one. Fourth one is simple one and the same like the other one. With return type. And with parameters. With parameters. Okay. So what am I doing is I'm passing the integer as return type. Okay, let us see why integer, and I'm even passing the parameters also. That is also integer type this time, because I'm going with the same example, addition of 2 numbers example, but multiple ways. I'll write here int C. C is equal to A plus B. Then I'll just return C value to the main function. Return C. Return C. Okay. Then main function I'm going to write here. So in the main function, I'm going to call that add function multiple number of times. I'll first time call 5, 6. When I call 5, 6, what happens? Okay, in the local variable A, 5 will be loaded. In the local variable B, 6 will be loaded. And the C is the data type integer type. Okay, this will contain the combination of both. And return C. C is what kind of variable? Integer. That is the reason I wrote here integer. I'm returning an integer value. Okay, if you return something, it has to get stored, no? So that's the reason I'm writing here D is equal to int D is equal to add 5 comma 6. Okay, now this D contains what? 11. So I'm printing that on the output screen. D contains 11. Okay, similarly I write add some 11 comma 12. Then immediately what happens? The control will go up, and this A contains, this local variable A contains 11, and this B contains 12. B contains 12. What's the sum? 23 will be computed, and that is being stored in D, variable D. What is this variable D? It is of integer type, because we are getting an integer value, no? Integer value has to be stored in integer variable, so I'm using integer variable. Percentile D, I'm printing the D value. Okay, this is the last one called with return type with parameters. Is it clear? Chalo now. Next what we have is, now I just, these things are only data variables. I have included only data variables. Now what I'm going to do is, I'm going to include pointer variables in this. The same base. Okay. You just see once again. Here the first one is with no return type and no parameters. That means void is my return type and I have no parameters. But still, my program can perform addition of two numbers. Yes. Again, second one. With no return type and with parameters. That means I'm not returning anything back to the main function, but it still contains the parameters. Okay. And I'm not returning anything back, so it is void. I'm printing the answer here itself. Still this particular function is doing addition of two numbers. Yes. Again this one. Here I'm returning something back and I'm not passing any parameters, no parameters at all. But still, I could able to do addition of two numbers, yes. Could we able to do addition of two numbers? Yes. Again the fourth one. The fourth one, here we have return type and parameters. But still we could, using this method also we could able to find the addition of two numbers. Now use the same addition of two numbers program I'm doing with an example of pointers this time. I just wanted to include the pointers this time. Okay. What I do is I'll simply write here add function, add. I use the first one, scanf. Read the values of A and B. C is equal to A plus B. This time, what I'm doing is, okay, I'll just declare A, B, C as a local variables. A, B, C as a local variables. Okay. This time, what I do is, I'm reading these values here itself, A and B, and computing the value of C here. Correct? Computing the value of C here. Yes. Yeah. Now, I'll simply make this C as a global variable, not the local variable. I'll tell you why. I'll make C as a global variable. Global variable. Now what I do is, I'll write my main function and I'll call my method called add. I did not write any return type. You just tell me what is the return type I must write. I'm calling this add function add 2 times. Okay. First time when add got called, immediately the control will go to this particular place. Then it is going to declare two variables like AA. Memory will be allocated for AA and B, and I'm going to read the values like 1 and 2. And the C value will be computed. That is A plus B is 3. Will be stored in a global variable C. Global variable C. Okay. We know that for every memory byte there will be one address associated with that. Correct? There will be one address associated with that. Okay. Now, I just want this address to be printed back. I just want this address to be returned back. I'll write here return address of C. Don't return the C value. I'm telling to return the address of C. Okay. What are we returning? We are returning address. Okay. I must tell this function returns the address. Whose address? Integer's address. This particular function returns the integer address. Okay, I need to write a prototype like this. Function definition has to be like this. Function syntax has to be like this. I am going to give the address. Address means which variable can contain the address? Only pointer variable. So I must write integer star. Okay. Then now I am getting the address back. Which variable has a capability of holding the address? Which variable has a capability of holding the address? Tell me which variable has the capability of holding the address? Only pointer variables. So that is the reason here I took one pointer variable D. D will get the address of C. Okay. Now D is a pointer variable which will get the address of C. That is 1x1. Okay. But what we want? We want the value or the address? We want the value. So what we write here? We write simply printf %d value present at D will give you the answer, that is 3. Okay, again immediately I'm calling one more time add. One more time add is being called. Immediately what happens is this memories will get discarded. Correct? Again new memories will get created. This time I'm reading 11 and 12. The computation will be done and the computation is 23 that will be stored inside your C. Okay. Again I'm returning address of C. Okay. If you return address of C, that address will be held into your D. Again this D here it will get overridden, or else the value of C will be, the address of C will be overridden into D. Okay. Then I'm going to use a printf statement to print the value present at that particular address. Okay. In this particular program I am interested in telling you how to write the return types. How to write the return types. Okay. Now just now I have shown you we have written what was our return type? Our return type was the address. Okay, whose address? Integer's address, some variable which is of integer, okay, which is integer type. So that address we are returning. Okay, understood? So what kind of program is this? This program is with return type, no parameters. That now similarly, I do the same program with the pointer variables. I'll just write here. This time I'll directly write the last method, that is int star add. I'm going to have even here also addresses only. I'm not going to give the value anymore. I'm going to give the address only. We can write the functions in multiple ways, okay? With using the reference variables or without using the reference variables, okay? With using the pointer variables or without using the pointer variables, okay? We can write the functions in multiple ways. I'll simply write here int. No, there's no int. I'll simply make int C as a global variable. C is equal to star A, value present at A plus value present at B. Return address of C. Whatever the value you are going to keep, that is there in this. Okay. Let us call from the main function. So we are calling add for the first time and I'm passing the values also. So here simply I write scanf, read the values into A and B. Address of x and y. I'm writing address of x and y because I just want to tell you that these variables are different from these variables. I'm passing the actual variables here. I'm not passing value, I'm passing address. So whenever we write int x, y, what happens immediately? Memories will get allocated, 2 bytes will allocated for x and 2 bytes will get allocated for y, right? Now I'm reading some values into x and y. Okay, 1 and 2 got read in using a scanf statement. Now I'm passing. I'm calling this add function. Okay, what am I passing? For every variable there is one address, correct? One base address for the memory location. That address I'm passing. That means I'm passing 1x1 and 2x1. That 1x1 and 2x1 are the address. Who has a capability of holding the address? Only pointer variables. So this particular place contains, this A contains 1x1. This B contains 2x1. Okay, then C is a global variable. I'm writing over here. This is called declaration part. Declaration part is nothing but the access right. What is the capability? It can able to hold only the address. But coming to the usage, this star A means get the value present at the A. What do you have in A? 1x1. Okay, go and get the value present at 1x1. That is 1. So here it is 1 plus get the value present at 2x1. That is 2. 1 plus 2 becomes 3. That will be read into your C variable. Okay. Now for every variable, as we know, for every memory byte there will be one address, right? Let us consider for C also you have an address. That address will be returned back. So what am I returning? I am returning address. That's the reason I wrote here pointer variable. I am returning address. Whose address? Integer address. Okay. Now we'll get the address back. Who has a capability of holding the address? Only pointer variable. So let me take one temporary pointer variable integer type and store the address into that. Then I'll print here what is the value present at that particular address. Is it clear? Have you observed what is the return type and what kind of parameters we have passed? All are reference types, all are pointer variables. Okay. What is this function called as? What is this function called as? With the return type, with the parameters. Is it clear? Okay. Now I'll tell you one more scenario. The scenario is we have I just wanted to pass an array to a function. For example, int, I'll write main function here, int main. In this main function, I have int array 5, 6, 1, 2. Okay, this is my array. I'll call the function called add, which will perform addition of all the array elements. I'll pass the base address to add function. I'll pass the base address to the add function. Okay, I'm simply calling it. Then the answer has to be displayed. So I'll write printf statement, printf %d. I'm calling this add function. Is it clear? Previously, I was storing this add value into some variable, but this time I'm directly printing it on the output screen. Okay, ma? So now what I do is I'll simply write here add. What are you passing? You're passing A. What is this A? A is array type, correct? Is it A array? Yeah, it's an array. What if you don't you pass only array variable A? What is getting passed here? Address, correct? What is getting passed here? Address. So I can simply write over here two ways. Int A, I can write in this way, like I'm passing the array. Okay, I'm passing the array. Then, okay, if you pass array, what should happen? I must do the sum of all the array elements. That means A of 0 plus A of 1 plus A of 2 plus A of 3 has to happen. So can I use over here sum is equal to 0, int s is equal to 0, int s is equal to 0, sum is equal to sum plus A of I. Can I do? Yeah, we can do. In order to perform the sum of the array elements, we generally do like this. What is this I ranging from? I is equal to 0. Do you people know what is the range of this I? Like how many variables are there in this? Do we know? We don't know. So for a while I'll write here I is less than 4 because I have got 4 elements there, I plus plus. Okay. So then after completion of this sum, I'm going to return back the sum. Return S. What is this S? What kind of variable is this? Is it integer number? So that's the reason write down over here int sum. Is it clear? Int sum. So that sum will be printed here. Okay. Then you may have a doubt. Okay, this 4 is there, no? This 4, just by looking at these numbers, I wrote 4. But if at all you want to make it as a dynamic way, like how many elements are there, we don't know. Then you have to find the length. How do you find the length of an array? Length of an array, how do you find? Length is equal to size of A by size of A of 0, correct? Size of A of 0, correct? This is how you find the length. Now this will give you 4, correct? Now this particular L also you will pass. You just pass here. You just pass here, or else make this L as a global variable. Global variable that will be accessed in all the functions. So instead of using 4 number, you can use here L. Okay, understood? Now we have passed an array of elements to the function, and this function is returning me only single value. Next, I have one more scenario. That is, I wanted to pass, I have a number, okay, I'm passing one number from the main function, okay, void main, I'm passing only one number from the main function, int n is equal to sum 6, find the factors of n. Okay, find the factors of n. Oh, I use a function name called factors only. I use a function name called factors only. So I'll simply use factors of n. I'm passing this n value to factors function. Okay, if you pass, I have to go and write the factors function. Okay, I'm writing factors function of int some n is mi, right? Because the same variable, but this becomes my actual variable. This is my formal variable. The same m is also containing now 6 only. M also contains 6 only. The same n value will be loaded into m. But the variable name got changed because it's a local variable now. So every time whenever the memory got created, whenever the function got called, new memories will get allocated. Then how do we find the factors for a variable n? For I is equal to 1, I is less than or equal to m, I plus plus, if at all m modulus I equal to 0, this I is considered to be a factor. But I said I don't want all the factors to be displayed. I want all the factors to be returned back. Return all the factors back, correct? If at all you want to return back, what you must do? You must store all these elements into array, because if I write simply return means it will come back. I don't want to return back immediately. I have to get all the values, then only I have to return back. So I have one idea. Idea is I'll take one global variable, global array, integer array, global integer array, and one k which is used for indicating the index value. One k which is indicating for the index value. Okay, initially these are my initial. I'll take them as static values. Why? Because it has to be shared. The changed value has to be shared among all the functions in my program. So I'm writing it as static int array and k. Now I'll store whatever the first factor you'll get, store that in a of k, that means a of 0, and increment your k value immediately. Because if at all the second factor comes, that has to get stored in a 1th index place. Now we have stored in 0th index place now. If at all we get the second factor, that has to get stored in a 1th index place. Okay. That is how I'm returning back. Okay. Should I return anything back? No, because already these are global variables. I need not return anything. So simply I write here void. I'm not returning anything. The values have already been stored in a static global variables. Okay. Now, in this program I'll write now printf. The factors are, where are the factors present? The factors are, where are the factors present? Yeah, where are the factors present? The factors are present in array, correct? So let me write here printf %d a of I. What is this I ranging from? I is a variable which is ranging from 0 to less than k. Why k? Because k indicates how many variables, how many factors we found and how many elements we kept in the array. Okay, this is how we find. Okay, understood? This is how we pass the array. This is how we'll get the multiple. Okay, here I am not returning anything back, correct? Let me say this k is there, no? This k is there, no? It is a local variable. Let us say this k is a local variable. So I'll write here int k. Let us say int k is equal to 0. It's a local variable. Okay. I have to return k value, because if at all we don't know k value, we don't know till where we have to reach. So I return k value. After this, I'll just return k value. What is this k variable? It's an integer now. So I'll write here, instead of void, I write here integer. I'm returning integer value. Okay. If at all you're returning integer value, who will hold that integer value? Someone must be there, no? So I'll write one more variable over here, k1. Okay. This k1 is holding that integer value. How many variables are there? I use this k1 only. Is it clear? Then I have, okay, you may have a doubt. If at all we make this array itself as a static, array itself as a local variable, then what happens? Okay, you can make array itself as a local variable. Done. Okay. Now, okay, you're writing. Can we written array? Can we written array address? Can we written the array's address over here? Yes, you can. You can return. But here we want k as well as a. This time what we do is we'll make only array as a local variable, k as a global one. We'll make array as a local variable and k as a local one. Let's move to like this. K as a global variable. I just wanted to show different variations, that's it. And I'm returning array's base address, that is a. A has to be written back. What am I returning? I'm returning array, correct? I simply write here, I'm returning array. Whose array? Integer array. I'm returning integer array back. I'm returning integer array back. Okay. If you are returning back integer array, some variable must be there which has a capability of holding that integer address, correct? So I write here simply b. Now this b has a capability of holding this base address. Then how do you print the value? Simple. I write here b of I. I write here b of I. Is it clear? Okay, this is how we pass the array elements back also. Is this clear? Then I have one more doubt. This time I want to make both of them. I just wanted to return k value as well as array value. Okay, what to be done? Can we return like this? A comma k? No. Return will return only one value, correct? It will not return both at a time. What we have to do? What we have to do is, you have to keep a and k in a structure. One global structure you take one global structure and keep the values inside them. This is, let us consider this is structure. Write down the structure first. Why do we go for structures? We know if at all you have different data types, then we go for a structure. What is the first one? It's an integer array. Okay, it's an integer array. What's the second one? What is the second one? It's a normal variable int k. Okay, this is global one. This is global array. So let me take s here. Okay, whenever we write s, this becomes s. And write down these. Don't return over here. Just write down here itself s dot s of k and increment the k value like this. Okay, is it clear? Now this s contains all of them. You are returning only s value. Return s. Okay, if at all you are returning s, what is this s? Who is this s? It's of struct ABC. So immediately your return type also will get changed. Your return type will get changed to struct ABC. Struct ABC. I am returning one structure type. That is the meaning of that. Okay. When you are returning s, someone has to be there to hold this structure, right? So that someone, I am writing that structure. That someone here. That someone I am writing here. I'll write here some variable t. Okay. What is this variable t? How much of memory we have to allocate? It is a variable which is able to hold this particular structure's address. Okay. Then I write here, okay, please allocate this much of memory for t. Struct ABC. Is it clear? Struct ABC. So this much of memory got allocated for this structure. Then how do you display the data? How do you display the data? It is there in the structure now. How do you display the data now? So all this data is contained in the structure. So first it is containing all the factors 1, 2, 3, 6. 1, 2, 3, 6 are the factors, and k contains 4 as its value, 5 as its value. 0, 1, 2, 3, 4. K contains 4 as its value. This is your A and this is your K according to the structure. Now I want to display them. How do we display them? Simple. For and as well, we have given this structure named to T, no? So this becomes our T now. S or T, both are same. S or T, both are same. So I'll simply write over here, for I equal to 0, I is less than t dot k. Okay, I is less than t dot k, I plus plus. What you're supposed to do here? Print. What you're supposed to print? Percentile d. You're supposed to print t dot a of I. Okay, all the factors you're printing here. Is it clear? Okay, this is how we can return multiple things from the function to the main function, and we can pass multiple things as a parameters to the function also. This is all about your function topic, and in the class we'll do, based upon this syntaxes, we'll do multiple programs in the class. Okay, see you in the class. Wrong time.